Rogue stars, wandering fire of the cosmos. Amid the grand celestial theater of the universe, there exists a haunting mystery: rogue stars. These exiled beacons of light drift alone through the silent void, far from the galaxies that once cradled them. Stars like our Sun typically stay loyal to their galactic homes, bound by gravity in a delicate balance. But not all stars share this fate. Some are torn away by unfathomable forces and cast adrift to wander endlessly. What gives these stars their freedom? And what makes them outcasts of the cosmos? Could our very own Sun, the anchor of our solar system, ever face such isolation? Today we explore the mesmerizing tale of rogue stars, lone wanderers in a universe teeming with light and life. Most stars are faithful denizens of galaxies. They cluster together in vast spirals or colossal elliptical galaxies, held in place by the gravitational tug of countless cosmic objects: planets, moons, black holes, and even other stars. This gravitational harmony creates the homes we call galaxies, where stars live out their lives in relative peace. In this family-like structure, stars tend to stay close, orbiting the galactic center for billions of years. Take our Sun, for instance. It spends its days comfortably nestled within the Milky Way's gravitational pull. But the universe is a place of chaos and motion, and not all stars are so lucky. Every rogue star has a story, an event so catastrophic or extraordinary that it breaks free from its galactic ties. These are no ordinary tales. They involve cosmic collisions, staggering explosions, and the invisible pull of one of the universe's most mysterious phenomena: black holes. Rogue stars, also called hypervelocity stars, become cosmic wanderers when violently hurled out of their galaxy into uncharted territory. They travel at incredible speeds, sometimes fast enough to escape even the gravitational pull of vast galaxies like the Milky Way. But how do such dramatic expulsions happen? At the heart of many galaxies, including our Milky Way, lies an ominous supermassive black hole. In the Milky Way, it's called Sagittarius A*. This gargantuan entity doesn't just sit idle, it exerts an immense gravitational force on everything around it. Occasionally, a star may stray too close to this colossal beast. When a star ventures near, the black hole's gravitational force can act as a slingshot. This is the incredible phenomenon known as a gravitational slingshot. One star, or sometimes a binary star system, two stars orbiting each other, gets caught in the black hole's immense gravitational pull. The close encounter disrupts the star's original trajectory, flinging it away at hyperspeed, so fast it escapes the galaxy entirely. What remains is a lone rogue star speeding toward the boundless void of intergalactic space. Not all rogue stars owe their solitude to black holes. Some are exiled by a beautiful yet devastating celestial event, a supernova. When massive stars exhaust their nuclear fuel, they die in violent explosions, spreading heavy elements across the cosmos. But supernovae don't just scatter stardust. They can also send their stellar companions flying. In binary systems, where two stars orbit each other, the violent death of one partner can disrupt the other's orbit. Like an unexpected shove, the explosion can launch the surviving star away from its home, hurtling into deep space. This leaves the rogue star to wander alone, tracing a solitary journey into nothingness. In the cosmic grand scheme, galaxies themselves are not static. They move, merge, and collide in a dance that spans billions of years. When galaxies collide, as the Milky Way and Andromeda are expected to in the distant future, their gravitational fields intertwine in a chaotic clash. Stars can become collateral damage during these galactic collisions. As gravitational forces jostle for dominance, some stars are thrown entirely out of either galaxy. Galactic collisions become the architects of countless rogue stars, flung far beyond their original realms into lonely intergalactic exile. Once expelled, a rogue star's voyage is eternal. These stellar travelers can reach velocities exceeding 1 million miles per hour, soaring through the universe with no destination, no home, and no companions. The vastness of intergalactic space stretches before them, a cold expanse of darkness and isolation. While stars in galaxies enjoy the company of millions, sometimes even billions of their stellar siblings, rogue stars are left completely untethered. Imagine their solitude: no solar systems to create warmth, no visible neighbors, just an endless journey across the infinite. Some rogue stars leave their galaxies entirely, breaking free from their gravitational binds to float forever in the dark expanse between galaxies. Their light becomes a lonely beacon, a whisper of life amid the void. Astronomers have identified several rogue stars, each offering a glimpse into the universe's violent processes. One such example is the hypervelocity star Chi 0437, 5439, which has been traveling through space at speeds close to 1.6 million miles per hour. Scientists believe this star was flung from the Large Magellanic Cloud, a neighbor of the Milky Way, after a close encounter with a black hole. These rogue stars provide crucial insights into the mechanisms that shape galaxies. By studying their paths, astronomers unravel the origins of the forces flinging them into the void, whether it's a black hole's grasp or a supernova's embrace. As we marvel at the lonely beauty of these stellar wanderers, a question arises. Could our sun ever become a rogue star? The thought chills the spine. After all, the sun is our cosmic anchor, binding the planets together in harmony. But what if that harmony were disrupted? For the sun to become a rogue star, it would need a close encounter with one of the forces capable of ejecting stars, like a black hole, a supernova, or a galactic collision. Our Milky Way's supermassive black hole, Sagittarius A*, is too distant to pose an immediate threat. Similarly, the sun's isolation from massive stars means it's unlikely to be expelled by a nearby supernova. Yet, one event looms on the far horizon: the future collision between the Milky Way and Andromeda. When this galactic merger occurs billions of years from now, the gravitational chaos could potentially affect the sun's orbit. However, most simulations predict the sun will emerge relatively unscathed, shifting within the newly merged galaxy's structure rather than being flung out entirely. In a deeply hypothetical scenario where the sun is ejected from the Milky Way, the consequences for Earth and its neighboring planets would be catastrophic. Without the gravitational anchor of the Milky Way, the sun would drift through space, carrying the solar system with it. Life on Earth would face an icy doom. Cut off from the energy and heat supplied by a stable environment, our planet would soon become a frozen wasteland. The very balance that sustains life depends on our sun's gravitational synchronicity with the Milky Way. The thought of the sun as a rogue star reminds us just how delicate this balance is, and how extraordinary it is that life has prospered within it. Beyond their mystique, rogue stars are key to unlocking many of the universe's secrets. They serve as messengers from the past, carrying with them clues about their origins and the events that launched them into their solitary journeys. By analyzing rogue stars' speeds and trajectories, scientists can reconstruct their violent histories, whether from encounters with black holes, supernovae, or galactic collisions. These stars show us the invisible forces shaping galaxies, the raw gravitational energy capable of sending stars careening into the abyss. Imagine the life of a rogue star. Alone in the unforgiving void it shines on, its light a whisper of its former existence. Devoid of planets or companions, it darkly glides across an infinite canvas. The intergalactic spaces it traverses are unimaginably vast, sparse and cold, stark counterpoints to the bustling activity of galaxies. Over time, rogue stars slowly burn through their nuclear fuel, their brilliance dimming over billions of years. As they fade into white dwarfs, their light becomes a fossil, leaving only the faintest glow in the darkness they inhabit. Rogue stars captivate the imagination, embodying both the violence and beauty of the cosmos. They remind us of the delicate balance governing a star's place in the universe and the forces strong enough to disrupt even the mightiest celestial dances. These stars speak to humanity's own wanderlust, the timeless desire to explore what lies beyond the familiar. Just as rogue stars drift fearlessly into the void, humans are drawn to comprehend the cosmic unknown. As the lights of the galaxies dance across the universe, rogue stars drift ever onward, untethered and unconstrained. Their lonely brilliance offers a profound lesson about resilience. They are cosmic exiles, reminders that even in solitary journeys, there's beauty and significance in simply shining. So the next time you gaze up at the night sky, let your mind wander. Somewhere out there, a rogue star might be blazing a trail through intergalactic space. Its light, though solitary, tells a tale of survival, a testament to the mysteries of the cosmos and the boundless energy that makes the universe beautiful, chaotic, and endlessly captivating.